My name is Antonio. The title of today's presentation is for STK 3033 Special Topics in Chemistry is Photocatalytic Fuel Cell to solve POME Wastewater. The members in our group are Kho Swen Jack, Ting, Pamella and Tiong, Xiang. Photocatalytic fuel cell is used for POME treatment and the catalyst used is titanium dioxide. The reason for choosing PFC is the entire fuel cell is driven by the solar energy, and generally, the photocatalysts used are zinc oxide, iron oxide, and titanium dioxide. The titanium dioxide and zinc oxide are commonly used because of their cost, eco-friendly, and their good chemical stability. Palm oil mouth effluent, also known as POME, which are wastewater produced from palm oil manufacturing. The wastewater has high BOD and COD, which are 25,000 mg per liter and 50,000 mg per liter respectively. The high amount of BOD and COD has severely polluted the environment, and thus POME has to be treated before releasing. Therefore, the objective of the projects are as follows: to propose a suitable method to solve POME wastewater, to utilize fuel cell technology, and fulfill the principles of green chemistry in solving POME wastewater, to determine the advantages and disadvantages of the proposed fuel cell method, and to explain the mechanism of fuel cells in mitigating environmental problems. In the project, the cell that used for treating POME is photocatalytic fuel cell, which consists of anode, cathode, and aqueous medium as shown in the picture. The anode is coated with titanium dioxide, which makes it as the photoanode. The concept of PFC is based on the photoexcitation and electron transfer. As the light is absorbed at the titanium dioxide, the photoexcitation is occurred and hence lead to the production of electron-hole pairs. Due to the potential difference, the electron flow from photoanode to the cathode. Moreover, photocatalysis will lead to the production of hydroxy radical, which is one of the strongest oxidizing agent, and it attacks almost every organic compound. After several attacks, the organic compounds become extremely unstable and eventually break down into carbon dioxide and water molecule. According to the findings, the use of the titanium dioxide as a photocatalysis in the PFC has 90% of COD removal rate and 68% of BOD removal rate. Turbidity and the color of the pollutants also shown high removal rate, which is 75% and above. However, the ammoniacal nitrogen only shows 33% removal efficiency. Furthermore, the removal of methyl orange has reached 90% using multi-cathode PFC. In the preparation of the photoanode, there are two methods that can be used, which are carbon coated with coated soldier solution of the titanium dioxide and deep coating method. And the setup of the PFC system will be as in the picture. To further improve the efficiency of the PFC, the electrolytes such as sodium chloride, sodium sulfate, and magnesium sulfate will be used. By examining the efficiency of each electrolyte used, the electrolyte with the highest removal efficiency is chosen. The initial concentration of the POME will also affect the efficiency of the PFC. Thus, the different ratio of the POME will be used in order to examine the efficiency of the PFC. The dilution ratio of water to POME is 1 to 400, 1 to 200, and 1 to 100. The pH condition of the solution will also affect the efficiency of the PFC. Therefore, several pH condition is chosen from acidic to alkaline for determination of efficiency of the PFC. The pH of the solution will be controlled by using sulfuric acid and sodium hydroxide.
For most of the chemical like titanium tetraperoxide, ethanol, hydrochloric acid, sulfuric acid, sodium hydroxide, magnesium sulfide, and sodium sulfide can be brought from the chemical company which is Sima Andrej Berhad at Selangor. The sodium chloride can be brought from supermarket. Well, the apparatus can brought on Lazada and local hardware shops. The total budget estimated is 797 ringgit. There are many advantages of PFC system. The first advantages is this system can replace fossil fuel which will finish soon as energy sources. Besides, the energy sources for PFC system is renewable and unlimited sunlight energy to cause photooxidation. PFC system can be used to degrade most of the organic waste like azo dyes and palm oil meal to act as fuel and generate power output due to the flow of electron. And last, the photocatalyst like titanium dioxide used is cheap, stable, and reusable to degrade organic waste. The limitation of MSC system at the application is extremely complicated and the use of bacteria need a lot of time to prepare. The power output produced from MFC system is also extremely low. On the other hand, PFC system can produce higher energy output, but the power generated still not enough to be applied to industrial level. Besides, the radical reaction produced to generate the organic pollutants in system are also limited as the reaction only takes place on the surface of the electrodes. There are too many factors will affect the performance of PFC system like type of light source, molecular structure and organic pollutants, dissolved oxygen in organic pollutants, fuel cell design, pH conditions, and so on. The final product, carbon dioxide, will cause the greenhouse effect to the environment. PFC system have achieved the 5 principles of green chemistry. First is principle 5, safer solvents and auxiliary. The solvents used are palm oil meal, organic waste, and water which have little or not toxicity. PFC also achieve principle 7, which is the use of renewable feedstock like sunlight for photooxidation process to produce electron hole and electrons, and also achieve the principle 8, reduce derivative. The unnecessary degradation like blocking groups and protecting groups are not included in PFC systems. The system also obeys the principle 9 catalyst and principle 12 inherently safer chemistry for accident prevention. Titanium dioxide is very stable photocatalyst and reusable used in PFC system, so it is safe to use to provide high surface area for redox reaction. In conclusion, titanium dioxide photocatalyst as photoanode used in PFC system is proposed to solve POME Wastewater. The proposed method meets the principle 5, principle 7, 8, 9, and 12 of green chemistry. This is our project timeline, which takes almost 10 days to finish. That is all for us. Thank you.